Today we will solve an example to understand the K-Medoids clustering methodology. We know that clustering is a method in which we form groups of data points. Clustering can be done with the help of K-means, and clustering can also be done with the help of K-Medoids. The difference between medoids and means is that means is always the central point, and medoid can be any point which has a high frequency. So let's solve an example, and we can with the help of example we can understand that how does K-medoids help us to do clustering. For example, we are given with these data points 1 2 3 4 5 6 7 8 9 10, and we can see that these are 10 data points, and these are the values of these data points. These are the x coordinates and these are the y coordinates of these data points. So for all of these data points, what we want to do is, in the first step we have to select some medoids. So for example, we say that this 1 4 point is my first medoid, and this 10 4 point is my second medoid. So once we have selected our medoids, in the second step we will find out the Euclidean distance of these medoids from all of the points. So you know the formula for Euclidean distance is x2 minus x1 square plus y2 minus y1 square whole under the root. So if we use this formula, we can find out the Euclidean distance of the first medoid from the first point. It will be 1 minus 5 whole square plus 4 minus 1 whole square whole under the root, and the answer comes out to be 5. You can see it from here that we have done 1 minus 5, and what is this? Yeah, 1 minus 1, because first point is my medoid, so 1 minus 1, and 4 minus 4, so it is coming out to be 0. And if I find the distance of this point from the second medoid, then it is 1 minus 10, it is 9, and 4 minus 4 is 0. So the distance of this first data point from the first medoid is 0, and the distance of this first data point from the second medoid is 9. So on the basis of this distance, in the next step we are going to assign these data points to the clusters. But just forget about this column right now. First of all, we will just calculate these distances. So for the first data point, I have calculated it here, and I have placed these distances on the top. Now for the second data point, if you find 5 minus 1 is 4, and 1 minus 4 is also 3. So the distance comes out to be 5. And if I find the distance of this data point from this, 5 minus 10 is 5, and 1 minus 4 is 3. So the square and the under root gives me the answer as 5.8. Similarly, for the third data point, the distance from first medoid is 4.47, and the distance from second medoid is 5.3. For the next data point, the distance from first medoid is 4, and the distance from second medoid is 5. For the fifth data point, the distance from first medoid is 9, and from the second medoid, because this point itself is the medoid, so the distance is 0. For the sixth data point, the distance from first medoid is 24, and the distance from second medoid, this one, is 15. And similarly, we will do the same for 7th, 8th, 9th, and 10th data point. So on the basis of these distances, whichever distance is small, you will make that data point part of that cluster. So for the first data point, this distance is less, and it itself is the medoid, so it will join the first cluster. The second data point will also join the first cluster. It is also smaller, so it will join the first cluster. And again, this is smaller, so the first cluster, and now this is smaller, so it will join second cluster, second cluster, second, and second. So all these points have joined second cluster, and the first 4 points have joined the first cluster. So now we are completed with step 1, step 2, and in fact the cluster assignment is also done. So step 3, assign clusters on the basis of distances of each point and cluster. It's also done in the table which I just show you. Okay, now the fourth step in this medoid clustering is cost calculation. The formula for cost calculation is, first of all, you do it for medoid 1 and then you do it for medoid 2. 1 4 5 1 5 2 and 5 4 were the points which joined the first cluster, and 10 4 25 4 25 6 25 7 25 8 and 29 7, these were the points which joined second cluster. So we have got these two clusters. The formula for the cost is ci minus xi whole summation, which means first of all you will take the cluster number 1. So the distance of 1 4, you know, this was your medoid, right? This was your medoid, this was your centroid, and so you find its distance from first data point. So 1 4 distance from 5 1, 1 4's distance from 5 2, and 1 4's distance from 5 4. So this point's distance from this point's distance from this, and this point's distance from this. So the first value is the medoid data point and the second value is the data point from which you are finding out the cost. So for this first cluster you will get 1 2 3 terms, and for this second cluster you will get this 10 4 distance from 25 4. So this point's distance from this point's distance from this point's distance from this point's distance from this, and this point's distance from this. So 1 2 3 4 and 5, you will get 5 terms. So this is your first term, 1 2 3 4 and 5. Okay, so this cost equation shows that we have to do the subtraction 1 minus 5 plus 4 minus 1. Basically this is the formula of city block distance. Similarly 1 minus 5 plus 4 minus 2, 1 minus 5 plus 4 minus 4, 10 minus 25 plus 4 minus 4, 10 minus 25 plus 4 minus 6, 10 minus 25 plus 4 minus 7, 10 minus 25 plus 4 minus 8. So all these distances will add up and they will make your total cost. So the total cost is coming out to be 108. So this is your cost number 1. Now we will repeat the step number 1, which means that we will select new medoids. So now we are selecting out of this table, we are selecting that our new medoids are 5 4, this is 5 4 and 25 7. There is no rule, it is just done randomly. Previously we took this point and this point as the medoid. Now we are taking this point and this point as the medoid. Okay, so after selection of new medoids, we will again calculate the Euclidean distance of all the points from new medoids. So what you will do, you will subtract 1 minus 5 whole square, 4 minus 4 whole square under the root. So this is the distance of first data point from the first medoid, and this is the distance of first data point from second medoid. Similarly, we will find the distance of the second data point from first medoid, 5 minus 5 and 1 minus 4. So this is the distance of second data point from first medoid, and this is the distance of second data point from second medoid. So in this way we will calculate the distance of all these data points from these two medoids, and on the basis of these distances we will again do the cluster assignments, which was our step number 3. So you see that these distances are small and these distances are large, so all these data points will join cluster number C1. However, these distances are large and these distances are small, so all these data points will join cluster number 2 or medoid number 2. So after this cluster assignment, we will again repeat the step number 3 and we will calculate the cost again. So for first cluster, now you have 1 2 3 4 5 data points, and for second cluster you have 1 2 3 4 and 5 data points. So these are total 10 terms. Total cost formula will again be the same. So basically total cost of this particular cluster assignment has to be calculated. The formula says that you will medoid point, you will find the distance between medoid point to non-medoid points only. So first of all, you know that this is your medoid point and this is your medoid point. So you will do 5 4 and 1 4. The cost of 5 4 from 1 4, the cost of 5 4 from 5 1, the cost of 5 4 from 5 2, and the cost of 5 4 from 10 4. Okay, so now in the second calculation we will find out the cost of this second medoid from all these data points. So the cost of 25 7 medoid from this data point, and the cost of this medoid from this data point, and the cost of this medoid from this data point, and the cost of this medoid from the last data point. So basically for 1 2 3 4 5 terms we will get 1 2 3 and 4, and for these we will get 1 2 3 and 4. So here we will get 8 terms, and the cost formula is again the city block distance 5 minus 1 4 minus 4, 5 minus 5 4 minus 1, 5 minus 5 4 minus 2, 5 minus 10 4 minus 7, 25 minus 25 7 minus 4. Hence the cost is coming out to be 20. Okay, so now we have to compare. In the fourth step we have to compare that the first cost was 108 and the second cost was 23. So if we subtract from the second cost, or we can say the current cost minus the previous cost, the answer is minus 85, which is less than 0. This cost, if we calculate, this is called swapping. If the swapping cost is larger than 0, we stop the algorithm, and the clusters which are found in step 1 are the final. Here this is not the case, so we will continue. We will continue because this swapping cost has came out to be negative. If this swapping cost comes out to be positive, then we stop the algorithm. So now we will repeat the step number 1. We will select two random non-medoid points, and now we will select two random non-medoid points, and we will recalculate the cost. So now we are selecting 10 4 and 29 7. You can see from the table that you can see that 10 4 is this point and 29 7 is this point. So previously we took 5 4 and 25 7. So now with these new medoid points we can recalculate the cost and we can do the swapping. So after swapping we will calculate the distance of all the data points from the new medoids, and then we will repeat the step number 3 and we will reassign the clusters on the basis of less distance values. So what we will get out of this is these are the distances of all the data points from this data point from this first medoid, and these are the distances from the first medoid, and these are the distances from the second medoid, and on the basis of smaller distances we assign them the clusters. And then once we made these clusters, then we will calculate the cost, and the formula of cost calculation is again the same, the medoid points to non-medoid points only. So you know that here you have this point as medoid point and this point as medoid point. So 10 4 from 10 4 to 1 4, from 10 4 to 5 1, from 10 4 to 5 2, and from 10 4 to 5 4. And then from 29 7 to 25 4, 29 7 to 25 6, 29 7 to 25 7, and 29 7 to 25 8. and when we calculate the costs with the help of city block distance, we get these values, and when we add them, the answer is coming out to be 46. So now again I find out the swapping cost. So the current cost minus previous cost is 46 minus 20, which is 26, and it is larger than 0. So we previously told that if the swapping cost becomes positive, then we stop the algorithm and we say that these are our final clusters. So although we started from a different set of clusters, we saw that initially in the very first step the clusters were different. The clusters were these, you can see the 1 2 3 4 4 data points were in the first cluster, and then the last 1 2 3 4 5 6 data points were in the next cluster. So you can see right now there are 4 data points in the first cluster, and 1 2 3 4 1 2 3 4 5 data points in the second cluster. So with the help of medoids, we have changed the medoids and we have formed different types of clusters. So this is how you do clustering with the help of K-Medoids. I hope you understand. Do like and share the video, and do write the questions in the comments. Thank you. Really, what we are doing it that now the cost is not reducing any further. The cost is now again has started increasing. So once the cost has started increasing again, it means that there is no need to continue the algorithm further, and you just stick with whatever clusters you have formed. As long as the cost is reducing and reducing, it is becoming smaller and smaller, so you keep on going. But as the cost has again started increasing, you will stop on and you will accept those clusters.